Imagine standing on a cosmic treadmill that's speeding up no matter how fast you run. The finish line keeps slipping away. That's our universe for you, expanding, accelerating, and teasing us with the ultimate cliffhanger. Will it ever stop? From Edwin Hubble's 1929 aha moment spotting receding galaxies to today's mind-bending dark energy revelations, the cosmos has been stretching its legs for 13.8 billion years. But is there a finish line, or are we hurtling toward an icy void, a fiery collapse, or something stranger still? In this episode, we'll dive into the science behind cosmic expansion, unpack the mysterious forces pulling galaxies apart, and explore the theories, some hopeful, some downright apocalyptic, about the universe's ultimate fate. Lace up your space sneakers, the race is on. To understand the universe's possible end, we need to rewind to its explosive beginning, the Big Bang. No, not the sitcom, though that might feel like it's been on since the dawn of time. We're talking about the real Big Bang, around 13.8 billion years ago, when space itself began expanding. Physicist Edwin Hubble first noticed that galaxies weren't just sitting around, they were zooming away from us. This led to the shocking realization the universe isn't static, it's growing. Initially, scientists thought gravity might eventually slow everything down. Picture the universe as a cosmic balloon, inflate it enough, and it might stop and collapse back into a big crunch. But in 1998, astronomers looking at distant supernova discovered something wild. The universe isn't just expanding, it's accelerating. Something was pushing galaxies apart faster and faster. That something was dubbed dark energy, the most mysterious force in the cosmos. It makes up about 68% of the universe, yet we still don't know what it is. Think of dark energy as the universe's invisible personal trainer, constantly pushing it to do more reps, whether it wants to or not. With galaxies flying apart and empty space expanding like an overachieving yeast dough, scientists began asking, where is this all going? And, more importantly, how does it end? Now that we know the universe is expanding faster than a toddler hyped on sugar, the next logical question is, how does this end? And for that, scientists have cooked up 3 dramatic endings. Think of them as the universe's possible season finale, each more mind-bending than the last. This is the fan favorite among cosmologists, and also the most depressing. In this scenario, dark energy keeps pushing galaxies farther and farther apart. Over billions of years, stars burn out, galaxies drift into isolation, and the universe becomes a cold, dark void. No new stars, no new planets. Just a lonely sea of dead particles floating through space. It's like the universe ghosted itself. According to NASA, this is the most likely scenario, unless something weirder takes over. Now imagine dark energy on steroids. Instead of a gentle push, it turns into an uncontrollable force that doesn't just separate galaxies, it rips apart everything. Galaxies shredded, solar systems torn to bits, atoms say goodbye. This is the Big Rip. According to this theory, dark energy's repulsive power grows stronger over time, eventually overcoming every other force in the universe, even gravity and electromagnetism. When that happens, everything from black holes to subatomic particles gets unzipped like a cosmic hoodie. The timeline, around 22 billion years from now, so you still have time to finish your Netflix watch list. Some scientists once hoped gravity would eventually win the tug-of-war against expansion. In this version, the universe slows down and then collapses back in on itself in a fiery implosion, like pressing rewind on the Big Bang. That's the big crunch. Some theorists propose that after the crunch comes a bang again. This is the big bounce idea. The universe collapses and explodes over and over in an infinite cycle, like a cosmic heartbeat. Sounds poetic, except there's very little evidence supporting it right now. That's where things get messy. Scientists use cosmic microwave background radiation, the leftover glow from the Big Bang, and the distribution of galaxies to study the universe's rate of expansion. The current numbers, thanks to tools like the Hubble Space Telescope and the James Webb Space Telescope, suggest expansion is accelerating. That puts the Big Freeze at the top of the probability charts. But here's the twist. We still don't know what dark energy really is. Is it a constant, a new field, a quirk of gravity we don't yet understand? If its nature changes over time, it could radically alter the universe's fate. And this makes cosmologists both excited and existentially uncomfortable. As Nobel Prize-winning physicist Saul Perlmutter said, "The more we learn, the more we realize how little we understand about what's driving our universe." Even worse, there's another cosmic curveball called the vacuum decay hypothesis. This delightful idea suggests that our universe might be living in a false vacuum, a temporary energy state. If a true vacuum ever forms, it would expand at the speed of light and erase reality instantly. Surprise! In short, trying to predict the universe's end is like trying to guess the final season of a show where every episode rewrites the plot and the writers are invisible. But the race is on, with telescopes, satellites, and particle physicists working overtime to crack the code before the lights go out. So what does an ever-expanding universe mean for us? In the short term, nothing too dramatic. Stars will keep shining, galaxies will keep swirling, and your local Wi-Fi will still mysteriously stop working every few hours. But long term, the implications are cosmic. A universe destined for a big freeze means every source of heat, light, and life will eventually wink out. No energy, no structure, no comeback tour. The Big Rip, on the other hand, suggests that the laws of physics themselves might betray us one day, stretching reality to the breaking point. And if the Big Crunch or Big Bounce proves true, it could mean that our entire universe is just one beat in a much grander cosmic rhythm. For scientists, understanding the end is key to understanding the now. Each theory reveals something about how gravity, energy, and time interact on a universal scale. But for the rest of us, it's a humbling reminder that everything, your house, your cat, your favorite pizza place, is riding on a giant invisible wave through space that may never slow down. The universe is expanding, yes, but it's also expanding our curiosity, our fear, and our awe. Whether we're drifting toward a frosty silence, preparing for a cosmic tear, or bouncing back in a fiery loop, one thing is certain: we're living in a universe that's constantly in motion, and we barely understand the engine behind it. Dark energy might be our greatest cosmic mystery, a force we can measure but not explain, influencing the fate of galaxies and the timeline of existence. So will the universe ever end? Maybe, maybe not. Maybe it already did once, and we're living in the sequel. But until we have an answer, we keep asking questions, keep launching telescopes, and keep staring into the void, because even if the universe has an expiration date, curiosity doesn't. Hit the like button, share this video with everyone you know, and subscribe to the channel. Thank you.